Morning.
Gonna wait just a minute longer to see if anyone else pops in here. Well, good morning to everyone who's here today. Good to see you all. If you haven't met me before, my name is Andrew Robinson. I'm the program manager at the Center for Nonprofit Excellence. We've been making a quick move to online learning, as I'm sure everybody has in their various roles and lives. Thanks for joining us, and please have patience as we work through this. There are a couple of other trainings coming up that I wanted to mention before we got started. So today we're going to be talking about PJ Rooney here is going to be talking about what our brain needs to help us through this time of uncertainty and to be successful in that time. Obviously an important piece. Other things that are coming up, we have some training specific to human resources on furlough and layoff. If you're on a board or in a supervisory role where you're thinking about those questions, we're going to have some more trainings around finance, on budgeting and scenario planning, some of those pieces as well. So I'll throw a link up to our upcoming trainings in the chat. So if you don't have your chat open, you could do that now. And it's also helpful to have your participant window open if you don't already, just to make sure you have a name there. And I invite anybody who's interested in changing their name to add their pronouns so that we can use people's pronouns appropriately in our conversation. We're hoping to have a more engaging session than what some people might expect from a webinar. So hopefully those of you who haven't joined us visually might be inclined to do so at some point and join in the conversation. I see that Laura has her hand raised. Did you want to add something, Laura? No, she did not. So if you do have a question, you can use that hand raise function to grab our attention, or get in this small group. Just throwing a hand up works fine, and feel free to unmute yourself and join in the conversation. So this is the second time we've had Dr. Rooney, who's new to CNE, although not new to Charlottesville by any means, join us for this session. Excited to have her back. She does a lot of things and has a lot of experience and expertise. She currently serves as the chief of staff at the U.S. Army's National Guard Intelligence Center, and works as adjunct faculty at the Brookings Institution, the FBI's National Executive Institute, and Mountain Shepherd Wilderness Adventure School, teaching leadership courses. She has this sort of broad understanding of behavioral science and leadership. Her education background is in counseling education, strategic intelligence, political science, and human development. So again, a great resource. Really happy to have her here to share that knowledge and expertise with us. And I'll hand it over to you, PJ. Thanks.
Thanks, Andrew. Good morning, everyone. Great to see you this morning. And as Andrew said, I'd like to make this as interactive as possible in terms of questions or something that's not clear. There's a lot of content. If you had a chance to just briefly look through the slides, there's a lot of information that I can focus more precisely on if you have interest in something in particular, or we can move through and and cover the top. So basically, this is a 2-day class. So that'll give you a sense of there's a lot of information that we could talk about in each of these areas. So I'll move to what your interests are. So please feel free to stop and ask questions or ask me to dive into something a little bit more deeply. It's such a broad topic when we think about the brain and all of its unique capacities. My experience in wanting to understand the brain is related to how we behave, both at home and in the workplace. So there's a lot of new literature out about it, and I'm happy to provide a bibliography or resources afterwards if you have an interest. So I'm gonna dive right in, and feel free to again stop and ask questions or seek clarity on something if you want to. Okay.
Yes. Just sorry to interrupt. I see that I accidentally locked the meeting. So there's a whole lot of people who will be joining us hopefully in the next 2 or 3 minutes as I let them know that they can actually join the meeting now. My apologies for that.
I think I did that. I don't think you did. I'm sorry about that.
That's okay. But feel free to get going and I'll just let them in as they come.
Okay, great. Thank you. So I'm going to now attempt to move over and share the slides. So as Andrew said, I'm new at this, so bear with me. And I want to see if I can keep seeing you at the same time. And I might not be able to. Wait, nope, share. And I'm almost there. And okay, I think I've got it. Okay, so the first thing I want to talk about is just a little bit about the basics of how the brain works. And the first requirement, basically, of the brain is to minimize danger and maximize reward. And that makes sense if you think about our brain's primary purpose is to keep us safe. So anything that feels like a threat is the first principle to move away from threats, to move toward those things the brain perceives as rewarding. So first and foremost, if the brain perceives a threat, it's automatically going to move into a mode that wants it to return to safety. So if you've ever had the experience where you're driving on the interstate and someone drives in front of you and you quickly move the steering wheel out of the way of the oncoming car, your brain does that automatically for you. It doesn't ask you, should we do something? So remember that as we move forward. So minimize danger and maximize reward are the two overarching principles of the brain. So when we think about the space that we're in today with the pandemic, it's no wonder that our brains are especially for watching a lot of the news, which tends to focus on the threats that exist out there. It's going to really activate the brain and some systems that can make it hard to think clearly and pay attention well. So that's the first component. The second thing is the brain is a prediction machine. It's constantly looking for to examine and observe what's happening in our environment to predict what's going to happen next. Again, based on that minimize danger, maximize reward principle. So it's looking for patterns all the time. In this picture here, we'll see a face, right? Most people see a face. This is actually an iceberg melting, but our brains are so used to predicting it will look for patterns in our environment. And when it doesn't, if the environment isn't matching a pattern that we have, it becomes anxious, and it will start to feel as though there's a threat present. So just realize that as you're going through the period that we're in right now, is your brain is going to be on alert because things are uncertain right now with what we're dealing with. Another important piece to understand is that we can change the way our brains respond to our environment. In the past, we used to think that that the brain was much more focused on being set. After high school, you have high school and college, you have about 86 billion neurons or nerve cells in the brain, and that's it. They're set and they have a certain structure, and that's the pattern they run. Well, that's not actually the case. We can actually go in and change literally by the thoughts that you think our structure and function of the brain. So let's look just briefly at what the environment is that we're in right now. And that is that we have, let me get this back up. We have a threat situation going on, right? So we have basically 3 levels in the brain. When we look at level 1 is in the broader environment. So when the pandemic, or when the coronavirus hit China, that was in a much broader environment, and we didn't have a sense that it was close by. So that's like level 1 threat for the brain. Level 2 is it got to Washington State, and then it started moving across the country, and now it's moving. So that's going to heighten the brain's sense of threat because it's in our neighborhood, heighten it to level 2. And then finally, it arrives in Virginia, it arrives in Richmond, and it's in Charlottesville. The threat is here, and the brain is very, very much on alert because we're seeing the threat right in our midst and in our environment. So remember, the brain is constantly looking to make sure we're safe. And if it doesn't feel safe, a whole number of things happen that I'm going to talk about so you have a sense of what's going on, and then we'll talk about how to manage that in this environment. Oops, now I can't do a page down. All right, I'm, for some reason, struggling with this morning. Oh, I know why. Okay, so now I can see you again. I'm going to try to go back to the slide, so I apologize for that. For some reason, I was able to do it better last time. Okay, there we go. So what are the big uncertainties we have right now? We have life-threatening health risks. We have health of our loved ones we're worried about, health of our friends and coworkers and the larger community. It's hugely uncertain right now. And basically the whole planet is consumed with thinking about what is this threat, how long is it going to last, and how do I keep myself and my family and my loved ones safe. And we also have uncertainties about our finances and our loved ones' finances, potentially our health insurance, our jobs, what is going to happen to the wider economy, whether we stay in a shutdown state or we open back up. So there's generally great uncertainty that's happening in our environment right now. So what happens to the brain when we have a lot of uncertainty? Because the brain is a prediction machine, it looks for to automate and for things to run on basic autopilot. When that is disrupted, the uncertainty is like rocket fuel for the brain. It really alerts the brain in a particular area, which we're going to talk about. So that uncertainty creates the brain basically shuts down or greatly diminishes its normal sense of safety in the environment, and it moves from one particular area to another. And we're going to talk about what those areas are. Another area of the current state is we have a lot of reduced autonomy. For example, we're not able to move around. We're not sure what's going to happen with our finances. We're not sure what's going to happen with our organization. And we don't have prior experience with this on a worldwide basis. So we're restricted in our movement. We have to wear masks or have been asked to wear masks. A lot of lack of autonomy, meaning I'm being told what to do as opposed to having choices what to do. And then what that does with our brain is when we have a loss of autonomy, whether that's a micromanager at work or being restricted and needing to stay at home, that creates a sense of arousal that we're in a threatening environment. So remember, micromanagement is not good for the brain at work, and neither is being restricted and having to stay at home in the current situation. So when we lose a sense of control, it increases stress. When we feel a sense of loss of choices, it increases stress for us. And I want to share just a little bit literally of what happens in your brain when we feel a sense of uncontrollable stress. The picture on the top right there, the hippocampus, that's a part of the brain that's a place of learning and memory. Over time, chronic stress literally reduces the size of the neurons in our hippocampus. They shrink back. So you'll see on the left, the apical dendrites are rather large and bushy. Over time, they get pruned back. to much smaller. So what does that mean for your brain? It has,
DJ?
yes.
Sorry, we're not seeing your slides right now. Did you want to?
Oh, I can see them. Okay, I didn't do share again. Okay, got it.
Thanks.
Thanks for that. Let me go back to share screen. I still am not sure. Okay, so can you see them now?
Yes.
Okay, good. So top right, hippocampus. That little bushy apical dendrites picture is a picture basically of one single neuron. And you see it has a lot of tentacles that reach other neurons. With stress over time, those get pruned back. On the bottom, where it says amygdala, you see that the little neuron on the left has very few tentacles, basically. Over time with chronic stress, those tentacles grow stronger. So hippocampus is a place of learning and memory. You want strong circuitry and good bushy neurons in there. The amygdala is a place of emotions, both good and bad, but in this case related to stress, bad emotions. And what you see is that muscle or those neurons grow stronger. So in the two components so far are certainty and autonomy. We have a lot of uncertainty, reduced autonomy, and relatedness. Our brains rely on each other. We rely on our other humans to be able to stay safe. Because we can't fly, we can't run very fast, we don't have talons to tear other threatening animals apart, we rely on each other. So we need social connection, according to the brain, the way it works, in order to survive. So our social supports are super important right now. And in our reduced ability to move around, it makes it really hard for the brain to feel calm or in a reward type of environment. Our brains are social, and without being connected to other people, our stress can grow and end up becoming chronic stress. Now, there are those of us who are extroverted and those who are introverted. Extroverts typically will have a wider group of connections. And while introverts have fewer connections, those connections are just as strong and provide comfort for the brain. So it doesn't matter whether you have a large group or small group, it's do you feel connected to that group? That's important, and staying connected with them. So those are our three really big key pieces. Realizing that the uncertainty creates stress for the brain, the lack of autonomy and control creates stress for the brain, and a lack of social connectedness creates stress for the brain. So I wanted to tell you just a little bit about the basics of the brain, so you have a sense of what your brain needs during this time of uncertainty. It's about 3% of your total body weight. It's kind of mushy. So if you were to hold it in your hand, it would kind of drain through like a custard. It is an energy hog. That's why there's a picture of a hog. It consumes about 20% of your oxygen and glucose as you're just sitting here listening to this webinar. When you're working on a project or intensely focused on something, it burns a lot more oxygen and glucose. So that's going to be important for us when we talk about strategies around this uncertainty, because your brain has to, in order to be able to function well, it must have oxygen. The two sources of brain fuel are oxygen and a type of sugar called glucose. The brain does not store energy. So that's a really important concept to think about. Most of our muscles are able to store energy. Our heart, to some degree, can store energy. Your brain can't store the energy it needs to function over more than about 4 to 6 minutes. That's why when we have a lack of oxygen to the brain due to heart failure, the brain dies very quickly because it doesn't store energy. So when you think about how do you replenish your brain's energy, one of the things you can do is get up and move around. That's why exercise is so good for the brain. It replenishes that oxygen and it replenishes the glucose. If most days you get up and you don't feed your brain anything first thing, you can expect by 11, your brain's going to be tired. So when we think about our brain is what helps us run. It runs everything within our body 24 hours a day. If we're not feeding it, it's not going to perform at its best. And in this time of crisis, we need it to be performing at its best. So realize that getting up and moving around and having some nuts or some fruit or some veggies in your system are super helpful for your brain to perform at its peak. Right, I'm going to go back to this, and I'm not sure exactly what you see, but okay. So
Do you have a question, PJ?
Sure.
Laura is asking, she's wondering if connection with others is comparable in person versus through a screen and a computer, and if you have a sense of whether that sort of gets to this sense of comfort that we get from other people or not.
It absolutely does. So being able to, even talking on the phone with someone that you care about and that cares about you, provides a sense of connection. What it doesn't provide, doing something like a Zoom meeting or being in person, doing a phone conversation, is it doesn't provide the closeness in terms of if you want to reach out to someone. However, these means that we're using, FaceTime or phone conversation or a Zoom meeting, are very helpful for the brain. Seeing the other person is better than just a phone conversation. But if all you can do is a phone conversation, yes, it provides a sense of connectedness that's very helpful for the brain. Very good question, actually. Okay, so let me go back to the slide. And sure why it's, there we go. Okay. I just wanted to briefly ask about areas that you're aware of where you feel a sense of autonomy, uncertainty, a lack of autonomy, and a lack of relatedness. In terms of feeling a sense of lack of autonomy, for many, that's the least that is impaired just when we're not at work. But having to change the way we're working, are any of you struggling with lack of being able to go out? How is that impacting your life? And are you noticing that that's creating stress for you? That's kind of a general question I had for you guys as we're talking through this. Thoughts on loss of autonomy and how it's related to your particular environment.
If you have something to add, feel free to unmute yourself and speak up.
Hi, PJ. I guess I can say that I've found that because you're not supposed to leave the house regularly, or supposed to group things into essential trips, that having to think so much more about everything I need and make lists and sort of plan more for those kind of outdoor trips is definitely sort of hard with the autonomy, because they're with the loss of autonomy. So instead of just being able to go out and pick something up, having to think so much more about everything I'm doing has definitely caused a bit of stress.
That's a great point, Anna, because even something like grabbing something, if you're going to go to the store to put on as a mask, even, is such a new component. And what the loss of autonomy over time does is it increases stress. And with that increased stress, it's this unfortunate double bind that we end up in, because the more stress we have, the less we're able to think clearly and with attention. And so if you're using great strategies in terms of writing lists and creating a routine before you go out. What's the new routine? I have a mask, I have gloves, I have a bag, I know exactly what I need, and I've thought through, okay, where in the grocery store do I need to go? So I go to those places and leave. That's a great strategy. And I'm going to talk through what happens when the stress increases. I'm going to talk through what happens in the brain and then what you can do about it. But what you're doing is exactly what needs to happen. So, but I certainly understand it is more stressful. Just running to the store to grab milk is not as easy as it used to be. Yeah. Any other thoughts by anybody? Okay, I'll keep moving on. Okay, for some reason, I end up not able to change my slides. Oh, wait, I think I found it. There we go. Okay. So I'm going to jump now into exactly to Anna's point, what's going on in the brain. So see the little red dot that says prefrontal cortex? That's where your conscious awareness resides. It's about 10% of your brain. And the rest, the other 90%, is non-conscious. It's your brain just operating on its own, doing all the pieces it needs to do to keep you functioning and healthy. For example, the pink part, the reptilian brain, that part of the brain is what we share with snakes and lizards and the reptilian family. That's where the regulation of our heart is controlled. Now, our heart has its own pacemaker, so it creates its own electrical energy to create a heartbeat, but it's controlled in this pink part. That's why it's so important and why brain injuries and strokes and swelling on the brain are so serious, because you see that the skull resides inside of a hard bone. There's nowhere for the brain to go when it swells due to a brain injury, such as a concussion. So what happens is it pushes down on that pink part, and as it swells and pushes down on that pink part, it affects our heart's ability to be regulated for a heartbeat. So yes, brain injuries, especially if you have kids, take them very seriously. I can't stand it when my son, he plays soccer, and when he hits the ball with his head on purpose, because I know it's not good for the brain. The second component is the limbic system. It's that little green part. So the pink part is the oldest of our brain. The green part is the second layer that grew in. That's where that amygdala resides. That's where we tag emotions to events that occur, whether they're positive or negative. But again, remembering that our brain's first and foremost function is to keep us safe, our natural go-to default mode then is when we have something happen in our environment, bless you, that's unpredicted, that's not what we thought, we will immediately think that that's a threat. This is the place where that happens. And we can build up the threat muscle by the thoughts we think or the experiences we put ourselves in. And that's going to be important for us when we talk in just a minute down the road about stress. The blue part is the neocortex. It's the least developed. It's only about 40 million years old. And it's a little bit more clunky. So realize that 10% of your brain is conscious awareness, and the other 90% is non-conscious, doing its regular functions, which is a good thing, because when we are driving on the interstate and someone pulls in front of us, we don't want to have to stop and think, what do I do about this? So I'm just laying the foundation now to kind of explain what happens to our brains during times of uncertainty. So another key part to remember about that 10% that's conscious awareness is your brain's braking system, your ability to stop yourself from doing something, right? So you're in a meeting where you're engaged with colleagues, and there's this email conversation going on between you and the colleagues. Someone says something that's maybe accusing you or one of your colleagues of doing something. It's 2 or 3 o'clock in the afternoon, and all of a sudden you find yourself going, reply all, right? Well, that's because in the late afternoon, our brain's braking system, our ability to stop ourselves from doing something, is tired. So you want to make sure you don't have surgery late in the day if possible. You want to make sure you don't buy a car late in the day. You want to make sure you don't ask somebody to marry you late in the day. Again, because our brain's ability to function at its peak has declined. And why is that? At the beginning of the day, when you wake up in the morning and you've slept well, you're rested, you grab maybe a handful of walnuts or a bite to eat in the morning, your brain is at its capacity. You have a full bank account for the day. Each time you stop yourself from doing something, or you make a decision as simple as, what am I going to wear? And you stand staring at your shoes or in your closet looking at the ties, trying to figure out what to put on, you're depleting that account. So by the end of the day, your ability to stop yourself from doing something has greatly been reduced. And that's why we spark at a significant other when we get home from work, or a kid, or we're struggling to emotionally regulate at the end of the day. Just realize that your brain's braking system is a small part of the prefrontal cortex, and its ability to continue to control that 90% that's non-conscious, especially the limbic system, is greatly diminished. So taking a few minutes at the end as you get home from work to just take 5 minutes to yourself, to settle, regroup, can be very helpful for your brain, given that its ability to stop itself from doing things is declined by the end of the day. I'm sharing, okay. And, okay, I'm getting the hang of it now. So now I'm going to jump into what happens when we move into stressful situations like we are now. So times of chronic stress, your brain actually in the prefrontal cortex, which is our place of executive processing. It's our ability to control our impulses. It's our ability to think clearly. Chronic stress shrinks the brain cells in that area. And again, when they shrink, they're connected to less neurons, and they're less able to control what's happening in the environment. So realize that chronic stress, not only is it bad for you physiologically, for your heart and your kidneys and other organs, it's not good for your brain. Literally shrinks your brain cells. And why is that? Let's look at this. I mean, I'm sure most of you have seen this before. You know, it's like your performance curve. If you don't have enough stress, because stress is good, stress is a good thing. You want to have some stress because what it does is it tells your brain that this is an important thing that we're about to do. So if I get sweaty palms before I'm going to give a presentation, or butterflies in my stomach, that's my body telling me this is important and I want to perform well. If I don't have enough stress, I'm inactive or laid back. If I have just the right amount of stress, I can be in the zone. That's what we talk about being in the zone. But if I have too much stress, it can lead to exhaustion and burnout, right? Our normal sine wave for not only the organs in our body, but our brain, is to mobilize and then restore. So mobilize for a big project at work and then have restore time. And this is about homeostasis. The body and the brain need to have balance. And I don't mean 50-50 balance. What I mean is mobilize, restore balance. So in those times where we are able to have some downtime after a big project has completed, your body returns to a state of balance or homeostasis. So think of it this way. When you have a situation where, I'm trying to think of a good example. Okay, so here's an example that happens to you every day. You have too much sodium or salt in your body. What does that mean? That means that your kidneys are going to retain water. And why are they going to retain water? Because you have too much salt in your system, and you have to have a certain balance for your heart and your liver to work properly. So when you have too much water in your system, a signal gets sent from the kidneys to the lungs. The lungs then send the information to the heart to beat faster, because you have a lot more fluid in there, and the heart has to keep pushing all that fluid through. And what that does is it sends a message to the brain saying, okay, we need to get rid of some of this, this sodium. We've got to get it out of our systems. So it'll absorb water to retain the sodium, to pick up the sodium, and then the sodium will get pushed out of your system through your kidneys. And then when it goes back down, your brain says, okay, we're back to normal. That is happening all the time in your brain, in your lungs, in your liver, in your kidneys, everywhere, in your heart. It's got to stay in balance. So again, in chronic stress, what ends up happening is we're not in balance. We don't have that system of expend and restore. So what does that look like over time? This is the environment we're in now. Mobilize, but no restoring. Mobilize or very little restoring. So what ends up happening? We get frustrated. And if it doesn't restore more, we become angry. And then if we don't restore, we become apathetic. I'm just going to, at work, do as little as I have to do to get by, and then that leads to burnout. So the energy expenditure and how you watch how you restore is really important. Your body needs to be restored, and especially your brain.
PJ, there was an interesting question that came up a little earlier, and I think it's still relevant. The question was when we're talking about that sort of bank of decision making,
Yes.
how does the difference between sort of making really deliberate, difficult decisions differ from when we're in this state of flow, if that makes sense?
Okay, sure. Yep, that's a great question. So normally what we do is our brain puts everything as much as possible on automatic pilot so we don't have to make decisions. That's why we get the same cereal. That's why we buy the same milk. That's why we automate as much as we can. If you've ever driven home from work and been intently thinking about something, and the next thing you know, you're pulling up in your driveway and you haven't been using any alcohol or substances, and you don't remember the drive home because your brain has put the driving on automatic pilot. And the reason it puts everything on automatic pilot, if it can, is because it uses less fuel to just run on automatic pilot. When we have to make decisions at work, we typically will go to what we've done in the past, again, because it doesn't use much fuel. When we have to make a deliberate decision and think analytically and deliberately through a process, it's much more energy intensive for the brain. So we can do that. And important decisions, you want to take the time to deliberately think through. And that's why it's really important to sleep on decisions you're about to make, because your brain will keep working on them while you're sleeping. It's very energy intensive to make the prefrontal cortex focus its attention on that one decision and the analytical components of that decision. I'm not sure if I answered the question. So what you want to do is those things you can automate, such as thinking the night before you go to bed, what am I going to wear the next day? Pack lunches for the kids the night before, or have them ready in the refrigerator to just throw in a lunchbox. Have a to-do list of the things that you need to accomplish in the morning before you head off to work. Those are super helpful because that frees up resources in the brain. And so those things that you can automate, do. Those things that need deliberate attention, find the time where you're most fresh. For some people, it's first thing in the morning. For other people, it's 10 or 11 in the morning, or after lunch. Find the time when your brain is the most refreshed to make those difficult or more analytic decisions. Again, it's because the brain will automate anything it can, a good habit or a bad habit. Smoking is basically a bad habit that the brain has automated. People who exercise can also be in the mode of, it's such a habit, I don't even think about it anymore, I just go and do it. So you want to automate definitely good habits. There was something else, Andrew, that you said that I was going to respond to.
I think there was, I'm wondering if, maybe I don't get the question exactly, if Laura, feel free to jump in, but this idea of flow, and what I'm interested in is like what counts as restorative. So like if I'm really working on an art project and pouring myself in, lost in that moment, how does that compare to being lost in a spreadsheet, for example?
So being in the zone or in flow, or having a flow experience, is because the brain is used to the experience and loves the experience, really enjoys the work. So there's not a loss in the same way as we have a loss under chronic stress. We can put ourselves in the zone in terms of the optimal amount of both expenditure of energy and the brain enjoying that expenditure of energy. Some people absolutely love working on a project. They're moving through it. They feel creative. They feel that the creative juice is flowing. That's being right in the perfect amount of stress where there's just enough to keep you performing, but not tipping you over too far where you feel tired. So yes, the brain, that's one of the forms of brain candy. The brain loves that when it can be in the zone like that. Often it takes a while of practice. So you hear basketball players being in the zone. You don't just get in the zone without practice. You have a little bit of practice to where your brain starts to feel like I can run a little bit knowing what I'm doing and not have to be focused super hard because I know what I'm doing. but let it go and let the 90% of the brain contribute to the product that I'm working on. Yes. The brain loves to be in the zone. Not too much stress, but enough to feel less the energy that you get from the stress. Yeah.
And you might have been headed there anyway, but someone's asking if you have any tips for habits we can create that will help refresh our brains throughout the day.
Yes, I'm getting ready to go there right now. So it's perfect lead into that. Okay. So let me go back to my slides. Okay. I'm going to skip. Okay. You know what? I'm going to talk about this briefly. So I mentioned this before. I just want to make sure you get this. Negative emotions affect the prefrontal cortex, which is our place of attention. Remember, that's our conscious awareness is the prefrontal cortex. The limbic system takes control. When we have a lot of negativity coming in, that little tiny 10% automatically goes offline when there's a lot of threat and uncertainty in the environment, and the limbic system takes control. Remember, because the limbic system's job is to make sure we stay safe and out of threatening environment. So what it does is it monopolizes our attention on ourself, and we lose focus, and we ruminate, and we ruminate, and we ruminate. So our ability to generate actions and makes decisions becomes a lot more energy intensive. Okay, so negative emotions, while the brain needs those in terms of making sure it's not in a threatening situation, rarely are we in a situation where we're threatened by our harm is threatened, we're running from a wild animal, for example. Okay, so strategies to recharge and conserve your energy. That's what we're going to dive into now, since there's a question about that. You're probably very well aware sleep is key. If there was anything I can say, sleep is probably the most important thing. And here's why. Because here's what's going on when you sleep. There are two hormones that are regulated or rebooted at night when you're sleeping, ghrelin and leptin. Ghrelin is the hormone that makes your stomach, sends a signal from your stomach to say we're hungry. And leptin is the hormone that's secreted from your fat to say we're full, we're done, topped off, we don't need to eat anymore. When you don't have enough sleep, what happens is if you have 6 or less hours of sleep, those hormones don't get properly recalibrated. So you wake up feeling hungry, even though you aren't expending more energy, even though you aren't, your caloric intake is the same. If you've ever gotten up for a summer vacation trip or to catch an early flight, and you just feel hungry throughout the day, but you're not expending any more calories than you normally do, this is why. Your muscles are sending a signal to your brain saying, we're tired, we didn't get enough sleep. So the brain interprets that as, oh, we need food. Okay, so stomach, let's get some ghrelin, let's secrete some gastrin to say we need to eat. So we end up gaining weight during chronic stressful times if we're not getting enough good sleep, because those hormones need to be rebooted. Another thing that happens at night when we're sleeping is in your brain and your spinal cord, your brain has tons of fluid in it, and so does your spinal cord. It sits in fluids. As you go through your day, the cells are doing their normal metabolic activity, and during that time, they have a lot of waste material, the hazardous material that's normally a result of your cells doing their normal duty. So what happens is the cells go about their day, they produce this hazardous material, and in the evening, they take the hazardous material out to the curb and they put it out as trash. When you're sleeping, that hazardous material, one of those is called beta amyloid protein. It's deposited out at the street, meaning in your cerebral spinal fluid and in the fluid in your brain, outside the cells, and it gets flushed out at night. It gets cleaned up. It's sort of like when the trash people come through and they pick up your trash at the curb at night or in the morning. If you don't get enough sleep, that protein builds up. That protein is the precursor to dementia and Alzheimer's disease. You want to be getting good sleep to have all those metabolic hazardous materials cleaned out at night as a normal function of your brain. Important function. Another thing that happens at night is cortisol. Is that, remember, you've probably heard people talk about the stress hormone being adrenaline and cortisol. Cortisol is highest in the morning, 5 or 6 in the morning. That's what wakes you up. It's going to help you start your day. As your day goes on, cortisol decreases so that at about between 5 and 8 at night, it's usually usually more like 7 or 8 at night. It's at its lowest as you're preparing to settle down and rest and go into your go to sleep. If you, like I often do, will get home from work and I'll be doing mom stuff at home. If I get tired at 8 or 9 and I push through it and I finish doing bills, or I am finishing up laundry and cleaning the kitchen, or whatever those functions are that you do at night. So at 11:30 or 12 o'clock, I'm ready to go to bed. Well, my body dumped cortisol in because I needed to stay up and keep working. So my body responded and did what it needed to do. So then I get in bed at 12 o'clock and I'm laying in bed like this going, why can't I sleep? Well, because my body rose to the occasion and did what I asked it to do, which was to push through when I was tired and dump cortisol in my system. Cortisol takes about 3 to 4 hours to run its course, unless you go out and do some very stringent physical activity, and then it will run through your body faster. So just realize that cortisol, if you can go to sleep at least 2 or 3 nights a week when you're tired, 9 o'clock, 10 o'clock, and get a good night's sleep, it'll have huge restorative effects on you, huge restorative effects. So realize cortisol is an important component at night. Your brain decides what to remember. You don't really decide throughout the day. When you sleep, your brain replays over and over instances that happen through the day that it wants to remember. And it moves it from working memory over to long-term storage. At night is when you consolidate your memories. This is really important for kids, especially, because if they don't get a good night's sleep, if their sleep is disrupted during a certain period, they won't remember and learn what they learned in school that day, because consolidation of memories happens at night. So again, sleep super important. And then of course, muscle and tissue repair and bone repair happen at night. Your red blood cells are grown in your long bones, most typically your leg bones. And why is that important? Because your red blood cells carry oxygen to your brain, everywhere in your body, but most critically to the brain. If you're not getting that area repaired, then it's harder for your brain to have that oxygen in the system. So realize exercise, again, helpful for keeping your red blood cells pumping out of your long bones, especially in your legs, good for the brain. And then the final thing in terms of restore is realizing that insulin regulation occurs at night. So those of us who are pre-diabetic or diabetic, whether type 1 or type 2, but pre-diabetic for those who are type 2, sleep is really important to regulate insulin. Insulin's required. That is the chemical that is required for your cells to allow intake of fuel. So realize that at night. Okay, so those are the big things for sleep. Naps are super helpful. So if you can take a 10 to 16 minute nap during the day, it's very restorative to the brain. Don't go longer than 30 minutes, because then you enter a sleep cycle where when you wake up, you'll feel tired because you've entered the deeper level of sleep. I'd go into that a little bit more, but I want to move over to exercise. Couple things key about exercise. Exercise grows new brain cells in the hippocampus. Remember, that's the place of learning and memory. So exercise is like miracle grow for the brain. Diets rich in omega-3 fatty acids are super helpful for that brain-derived neurotrophic factor. So exercise, super important. And we're not talking about gobs of exercise at first. If you haven't been exercising recently, start small, 10 minutes. Go walking, get your heart rate up. Because here's what happens. Here's a picture of a neuron growing and basically expanding as you try a new activity, as you're learning something new, the neurons, literally their ends, the bushy ends, split. So within 90 minutes of practicing or pushing yourself on a new activity, you actually see the neurons split. And then what happens is, I know this is a little bit overwhelming, I just want to point out the components across the top. The axons literally will grow new network bushy ends to extend to more brain cells. They will actually grow new capillaries to support them. And as they do that, the neurons actually split and you have more brain cells. That's called neurogenesis. And then on the right where it says angiogenesis, as you grow new brain cells, okay, you're going to get more capillaries in there to supply them. And then you're going to grow more hazmat team or the microglia that clean up all those hazardous materials in the evening and at night while you're sleeping. The third component, so sleep, exercise, really important, mindfulness. Mindfulness is brain candy, okay? It's a mental discipline where you're just focusing your attention. You're using your mind to act back on your brain. Okay, that sounds very woo-woo, right? And what I want you to understand about mindfulness is if you allow your brain to drag you around and you don't control your brain, then it will do what it wants. Think of it as a muscle. Use your mind to act back on your brain to strengthen it in the areas and the ways that you want to, as opposed to it dragging you around. Have you ever met anybody at work who's constantly negative, constantly limbic or postal? Those of you who are old enough to know the concept or the phrase going postal. Going limbic is the same idea. It's this negativity all the time. Well, we can train our brains not to do that. So we increase the prefrontal cortex muscle and decrease the limbic system muscle. And as we do that through sleep, getting good sleep, through exercise, and through mindfulness, I'm not talking about becoming a yogi. I'm talking about 10 minutes in the morning and 10 minutes in the evening, where you take time for yourself. You can use it. There are several good apps out there. Headspace is a good app. Beautify, Calm. And basically what you're doing is you're strengthening the muscle that is the prefrontal cortex muscle that helps you emotionally regulate, that helps you stay in the prefrontal cortex as opposed to moving to the limbic system, which is non-conscious, which drags you around. Mindfulness is super helpful for decreasing anxiety and stress, and it's super helpful for being able to think clearly during times of distress. Get back to this. In addition, I want you to understand that it is about strengthening awareness, but it's not clearing your mind. It's not controlling your thoughts. It's not a quick fix to something that's unpleasant. It's basically building up the muscle of you controlling the thoughts you think. Focusing on breathing, focusing on, you can do mindful walking, you can do mindful eating. It's slowing down and focusing on what's happening in the present moment, because that's very calming for the brain. I put in the slides just some really great research done at Harvard Medical School about the significance of mindfulness. I'm not going to go through this, but I want you to see the vast areas that mindfulness is used in lots of different ways to decrease people's stress. Again, stress is not good for the brain, especially chronic stress. And so social connection, really important. So scheduling a Zoom or FaceTime or eating with loved ones on Zoom, great and super helpful. Sending a video message to a loved one, sharing photos with family, sending songs to family through a text or an email, or just getting on your phone or FaceTime together and watching a movie together. Who are those people in your network that you haven't reached out to in a while, that it might be fun to just reach out and say, I'm thinking of you, I hope you're doing well. Gratitude, I'm working on including gratitude into this presentation as well, and I know I'm running out of time, because gratitude is super helpful. As we build up that muscle of our prefrontal cortex and decrease the stress, what we find is gratitude is a function that, along with sleep and exercise and mindfulness, can build up that, the brain's, again, it's like brain candy. So just sending a short letter or email to someone to just say thank you for something, is another tiny thing you can do in your day. So what does my day look like? Literally, what does my day look like when I'm not going to the office? My day looks like I do brain training in the morning, about 30 minutes, because I have noticed my attention is declining and I need to beef it back up. So I do brain training. I do a gratitude note. Usually it's a snail mail note. And I try to exercise at lunchtime. I'm not a big morning eater, so I'll eat a handful of almonds or a little bit of yogurt because I'm not hungry in the morning, but I know my brain needs food. I drink a half a gallon of water a day. So you want to definitely drink water because your brain needs the H2O in its system because it's mostly water. The brain is mostly made of water. And then intermingled throughout there, it's working on reports or answering email. So it sounds almost too trite or too easy, but it's exactly what your brain needs for it to function at its peak. So I think I have just one more. This is the last slide. Creating structure where you can. That's what I was describing what my day looks like when I don't have to go into the office. Structure is really helpful because it shows the predictability for your brain, and your brain can expend less energy and resources because, again, the brain's an energy hog. Walking, yoga, stretching, using YouTube videos to just do 15 or 20 minutes a day can be super helpful of just movement, any kind of movement you enjoy because you need to be motivated to do it. Eating healthy, really important. Not every day, 3 times a week, 4 times a week. So you don't want to have fast food. You don't want to do pizza 4 or 5 times a week. You want to eat healthy at least a few times a week because it really helps your brain. And then using mindfulness to have your mind act back on your brain are all tools and tips you can use during this time of uncertainty. So those are oh my gosh, almost right on time. So I want to open it up to questions or thoughts or ideas you might have that would be helpful to share with the rest of us.
There was one question that came up earlier from Jimmy Trost, and he was reading about some the way the brain ages, and was curious about the way that the stress from the particular situation we're in now might be affecting or be able to be processed differently by younger folks versus people who are past 30 or 40 years old. So
a couple things. The brain does shrink as we age, and so that's why these ideas about sleep and exercise and keeping your brain fit are really important. It shrinks on average about 1 to 2% after we hit about 40 to 45. So you can do things to strengthen your brain and decrease that normal shrinkage that occurs with aging. In terms of brain circuitry, those in their 20s and 30s don't have the experience that someone who's in, on the 50s and 60s, and to be able to assess a situation, oftentimes work-related, in the same way. And so what does that mean? That means that typically someone in their 50s and 60s will have had more experiences to be able to realize or recognize what's happening and can go to a fix or a solution sooner than someone who has less experience. However, those who have less experience are often more open to looking at alternative ways of meeting a challenge or a problem at work. So it's a complement of both of those. If you can bring an example of this is I don't process, I'm not a linear thinker. I'm more of a big picture thinker. So if I'm at work and I have to detail out something that's a new process change that we're doing at work, for example, I will go and borrow somebody's brain. My colleague Leah is a great process linear thinker. And I'll say, Leah, think this through with me. Talk me through what you're thinking as I describe this, because I borrow her brain because she has that skill set. I do similarly with the 20s and 30-year-olds at work. If I'm having a particularly difficult challenge, I'll say, how do you see this? Explain to me your thoughts on this. So we can borrow each other's brains depending on where our strengths are. For those who are younger, have less experience in the workforce, they'll come to me and say, what have you seen in the past? What are the challenges that you guys have come up against before that we need to be aware of as we're trying to make this change? So be aware that, borrow each other's brains. If you have a strength in a certain area, let people know that and find out what your colleagues' strengths are. So when there comes a time where you need to borrow their brain because they think in a more effective way than you do, then ask if you can borrow their brain. So in today's environment of uncertainty, we're all in the same mix. Those of us who have experience in the workplace haven't experienced this before. Those who were younger haven't experienced this before. So we really need each other to come together to bring what skills our brains naturally have to help each other out. I hope that answered the question.
Thanks, PJ. I'm realizing it is 10 o'clock. I'm just wondering if you'd be willing to stick around for 5 or 10 minutes in case people do have more questions.
Absolutely, yes.
Fantastic. So thanks to PJ and thanks for everybody coming. I will send a video around to folks afterwards. If you do have a question for PJ, feel free to stick around, unmute yourself and join in the conversation.
Thanks, everybody. Thank you, Andrew.
Thanks a lot. Anna, do you have a question?
I do. PJ, I was wondering if you could talk a little bit, if you can, about sort of coping with the unknown. One of the things that is hard for me to deal with right now is I worked so hard to get used to my new job and office environment, and now triple as hard to get used to working at home. And then that sort of timeline of like, is this permanent? Is the brain space, should that be used right now to get 100% used to this? And then what happens, like it's just this loop of like, then you have to get ready to get reused to going back to the office. And like, there seems to be this sort of feedback loop that is really hard. And I'm wondering if you have any thoughts on that.
Sure, there are two things, Anna. The first is definitely creating a predictable day as much as you can for yourself. And the other piece is because each day is bringing new information, whether it's we're staying in, we're moving to a lockdown state, or we're moving away from a lockdown state, as much as you can, stay in the present and those things you can control. Don't leave the news on. Watch it once a day to get what you need, but don't be checking, turn off any feeds you have on your electronics and don't watch the news. And stay focused on what are those small things I can control and that I can make predictable in my environment, because the rest is just going to heighten the threat response in the brain. None of us know, and in so doing, create your small, predictable day, and stay focused on the day, not more than the next day. I know it's hard though. It's so easy to say, but it's hard to do. Once you build up that muscle, you'll get better at it and you'll feel more in control because you're using your mind to act back on your brain. Yeah, great question though.
Thank you.
Anybody else have any questions or? Thank you, Andrew.
Thanks. Can I ask one more question? Do you mind?
Yeah, no.
I'm curious, when you're talking about, you're making this mind-brain distinction, are you talking there about sort of the conscious prefrontal cortex versus those automated pieces?
So that's a great question. That's the distinction I'm making. However, in the literature, in the neuroscience literature, that's not a distinction they make. There's still a lot of debate about the difference between consciousness and the mind, and where does consciousness reside. I think it's simplistic to say consciousness only resides in the prefrontal cortex, because there's a lot of this other area, I think I mentioned this to you, that I'm working on is really understanding the gut-brain axis. And the gut is considered the second brain, because there are neurons and our gut and other organs actually get information from the external world and send that information to the brain. But we don't know exactly how or why it's picking it up. So when we talk about consciousness, there's a lot of interesting conversation about where does consciousness reside, because it also resides in the body, but we're not able yet to really say much about, okay, so where and how. And there's more of the neurotransmitter serotonin, which is a brain chemical too. More of that is made in the gut. The gut has more neurons than anywhere else, or nerve cells than anywhere else than the brain in the body. So it is a huge receptor for information, and you'll hear some people talk about energy and picking up energy from the external world or from other people. That energy is being absorbed not just in the mind or in the brain, but other places. And so there's a lot of debate about where consciousness resides. And I think it resides in the whole body. But yes, I was making the distinction between the prefrontal cortex and the other 90%. But there's a huge other world in the gut-brain axis that's just on the cutting edge right now, that's going to have a whole lot of information. And with regard to disease, a lot of new information is coming about the foods we eat impact our gut, and our guts impact the diseases we get. So yeah, I sort of didn't really answer your question, because it's so new right now.
Yeah. Thanks.
Yeah.
I appreciate it. Was there anybody else who's still hanging around that had a question for PJ?